One is a little bit different than our notes because there's only one variable. I don't know how that problem snuck in there, but that's okay. A big problem that I saw yesterday was we started expanding everything out and putting it in a fraction when we were using the product rule, like on the entire front side. There should be absolutely no fractions on the front of this worksheet, okay? So number one, if we expanded that out, it would be 3 times x times x times x times x times x times x. Right? We got a 3 in front, x to the third, and another x to the third. Well, there's nothing to multiply my 3 by, so we'll leave it as 3. But how many x's do we have in total? 6 of them. 3x to the 6th. Right? Now the way that we talked about in the notes, just so we can review that, is we highlight those coefficients. We highlight our x's. This is more from last Friday's notes than it is from yesterday's because there's only one variable. 3 times 1 in front, x to the 3 plus 3 behind it. But that still gives us 3x to the 6th. So it all depends on how you understand this work. If you understand it better by seeing every single factor split up, by all means, please go ahead and do that. Just don't put them in a fraction unless they're already in a fraction. If you prefer the kind of rearranging and shortcut way, by all means go for that too. As long as you do everything mathematically precisely, yeah, that's what I meant. You will get the same answer either way, right? As long as you're careful and precise, just like that. Okay. Down to number 6. Now here we've got an interesting situation because we've got an x to the 0th power. So I'm going to go ahead, I'm going to expand all this out. I've got a y. Now, if I have x to the 0, how many times am I going to write out the letter x? 0 times. What am I going to write instead? Well, what is x to the 0th equal to? 1. Right? That's where I think a lot of the confusion may have come from there. X to the 0th is just 1. And then we have 4 times x times y times y times y. Right? So 4 times 1 as our coefficient gives us what? 4. How many x's do we have total? Just one of them. And how many y's? 4. 4x y to the 4th. Okay. Yes. Good question. If you wrote it 4y to the 4th x, that is technically not wrong. It's the same exact expression. And I think I mentioned this to a couple people yesterday. I would get in the habit of putting them in alphabetical order from left to right. I personally don't mind, right? But I can't promise that your high school math teachers won't be as, lenient or whatever. They might be picky and be like, oh, this is wrong because x is supposed to come before y. So just get in the habit of keeping it alphabetical for now. Yeah. What's that? For number 6? As the answer, 1 over x? Oh, you mean like put a 1 right there? That's totally fine too. If you feel more comfortable putting the 1, that works for me. It's just, that's our invisible one that we don't have to put. Because we know it's technically there. Yeah.
I already crossed it off wrong and put the other.
Oh, that's okay. Wait, you put it like this?
Yeah.
Oh yeah, no, that's fine. Just remember, our invisible one means that it can be invisible. We don't need to write that 1. If we have one single x, it's just x. But it's not wrong to write x to the 1st. It's absolutely correct. It's like, it would be like your English teacher, being super picky about where you put your comma, To you, it's like, well, you read the sentence, fine, you know what the sentence is saying. But as the teacher, they're like, no, the comma goes there. It's the same type of thing in math, right? There's like kind of math grammar that you're supposed to that you should follow, but it's not the end of the world if you don't. Just like in English, it's not the end of the world if you don't have a comma, even though it may feel like it sometimes. That's why I can't teach English. Anyway, on to the back, we got number 13. I almost taught English because I wanted to teach theater, but here we go. So number 13, now we got a lot more going on here, right? So if we were going to expand this out, we're going to see that we have tons of factors in total, right? If we write our 9, x to the 6th means we've got 6 x's. Y to the 5th means we got 5 y's. Then we've got a 6, 4 x's after that. And y to the 0th power, which is equal to what? 1. So we're not going to write out any y's there. Okay? I'm going to count up my x's. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I know I'm going to have x to the 10th power somewhere in there. How many y's do I have? 1, 2, 3, 4, 5. Double check and make sure you didn't put y to the 6th if you accidentally counted that y to the 0th. And then what's my coefficient in front going to be? It's going to be 9 times 6, which gives us 54. Just like that. See a couple Chromebooks out. Just want to remind you that, this is how we confirm if our answers are right or wrong on our homework. So just want to make sure that's not distracting us. We are going to be on the Chromebooks here in a second, as soon as we get done with this. But I'd prefer if you focus on this right now. Okay. We got 3 more to get through. But again, you could have done this x to the 6 plus 4 times y to the 5 plus 0. With that 9 times 5 in front, you would have gotten the same exact thing. 54, x to the 10th, y to the 5th. So this is like from our notes. But in 6th period, we found that this way was a lot easier for a lot of people because we're used to splitting it up once we get down to number 16. But again, it's up to you. Completely up to you. All right. 16, we got another one of those ugly 0 exponents here. So if we were going to split this up, right? 4 is 2 times 2. There's only one u and one v. On the bottom, we have 2 times 2. And then what was u to the power of 0 equal to again?
1.
Just 1. Not u, not 0, but 1. So what can we cancel from the top and bottom? Anything? We can cancel a pair of 2's and another pair of 2's. All that leaves us with is uv over 1, which we can just write as uv. If you wrote uv over 1, again, totally fine. It's another invisible 1 just as a denominator instead of an exponent. They're the same exact thing. Okay. Thumbs up. Anyone get uv for 16? Oh, nice. Good. Okay. Perfect. Perfect, perfect. 2 left. 22. Oh, man, all of these have a 0 exponent. That must have been tricky, which I understand. Oh, this one is really, I don't like 22. So 22, on the top, all we have is x. On the bottom, we have an x. And then what can we write y to the 0th power as? 1. What can we cancel from the top and bottom here? A pair of x's. That leaves us with 1 in the denominator. What's that? Thank you. And what do we have left in our numerator? If everything on top cancels, what do we have? What do we have? Not 0, but 1, right? Thank you. Sorry, I couldn't hear you over the lawn care. And 1 over 1 is just equal to 1. Boom. That's our answer. Ugly question. Very simple, nice looking answer. All we've got is 1. Okay, questions on 22? Anyone get one on their own? Cool, I see some thumbs up, I see some heads nodding. It's great. Now, 23. Again, all we have on top is y. On the bottom, we have 3 times y times x times x. You you may notice that this question is not in alphabetical order. So it's not technically wrong if the y comes before x. It's just one of those, math grammar things that you should pay attention to. But it doesn't matter here because what are we going to cancel out? Y. Right? So again, everything on the top is gone. What are we left with? A 1, right? The y canceled out. So if everything cancels out, just like we saw up here, we have a 1 in the numerator. I know I have a 3 down below, but what else do I have after that 3? X to the power of 2, right? 1 over 3x squared. Just to see if you guys remember from our 2.1a, how could we write this with a negative exponent? What would it look like? Anyone kind of see the pattern from 2.1a there? You know what I mean? We've got the 1 on top, positive exponent on the bottom. If we wanted this to be a negative exponent, how would this look? Any ideas?
1 over 3x.
Very close. We are going to have 3x to the negative 2, but there's not going to be a 1 on top. It would just be that. Right? Let's review here for a second because this is important. You see what I mean? If we had 3x to the negative 2, right? We put it over 1, flip it around, 1 over 3x squared, or 1 over 3x to the negative 2, and then we make that negative 2 positive, right? So this converting back and forth, this idea is going to come into play today. We're finally done with 2.1. That was the longest single lesson humanly possible. So we're going to move on to 2.2 today.